is Jane Disney, and I'm the Director of Education here at MDI Biological Laboratory, as well as the Director of the Community Environmental Health Laboratory. I'm the Principal Investigator on the SEPA grant, which is a 5-year project to engage teachers and kids in Maine and New Hampshire in monitoring their well water for arsenic. And this is a collaborative project with Dartmouth College. Well, the Community Environmental Health Laboratory is a pretty unique lab. We actually engage citizens as scientists, and we have been doing that for over 20 years in a variety of projects. We've had people involved in monitoring beach water and monitoring the oceans for toxic phytoplankton as part of statewide initiatives. So in the recent years, we decided to get involved in some groundwater issues that were emerging in the state of Maine, one of them being the contamination of well water with arsenic. You know, originally we were doing mostly surface water contamination work, and it was just sort of a natural thing for us to transition into groundwater. A lot of the surface waters that we were looking at had the potential to infiltrate and contaminate groundwater as well. And certainly people called us all the time from our communities asking, could we look at well water as well as surface water? So in response to our community and what we saw as an emerging issue, especially with what we were learning from Dartmouth College and all of the work going on in their Superfund research program, we decided that the time was now to engage people in monitoring for water. We knew how to do it. You know, we had a long history of working with all kinds of community members and with teachers and students. So we wrote an EPA environmental education grant and had a couple of years of funding to pilot a study, and we were involved with Dartmouth in that study. One of the things that came out of that study is that there was a lot more arsenic in wells and a lot more wells that were contaminated in communities than were thought before. We did engage with teachers and students in sharing this information with their communities. But one of the things we noticed is that it was a struggle for the teachers and students to really analyze and understand the data and communicate that effectively to community members. So a focus of this new grant is data literacy. We're specifically inviting teachers to MDI Biological Laboratory to receive some training both in data collection and data analysis. Along these lines, we've partnered with tuvalabs.com, which is an online data literacy program that has been working all around the country to try to get teachers and kids more comfortable with data and better able to speak about the findings that they have. And one of the ways that we're going to really be able to effectively keep these projects going in these diverse geographic areas is by engaging partners from local colleges. So we are integrating into this project a scientist mentor teacher relationship. So for example, we have Colby College down in central Maine that's going to be partnered with Waterville High School. Our own institution, MDI Biological Laboratory, will be partnering with local Trenton Elementary School and Tremont Consolidated School. One of the amazing things about this project is the way teachers and their scientist mentors are going to work together with students to host community meetings and let everybody know what's going on with the well water. We did some of this in the original EPA project. It was very powerful, and people were really receptive to what they were hearing. So we're really hoping that the students can do what we call moving data to action and really be citizen scientists in their communities who are collecting real scientific data and then sharing that data out in the hopes that some action will be taken that will affect public health. My presentation, and I don't think it should take too long because we certainly have all weekend that we can talk about the project, but I'm trying to give you, first of all, an introduction and overview to the lab here so you understand the context in which this project is happening. And then also I want to just walk you through kind of the elements of the project that were planned for in the grant, and then more specifically what's going to happen in this workshop this weekend. So I'm just going to be taking you down in levels of detail until you know what you're doing in the next hour. So the thing is, the MDI Biological Laboratory has a really long history in research training and mentoring. So we have a lot going on in that area. This isn't the first time that we have ventured into this area of research training. In particular, we're the lead institution for the main INBRE grant. And INBRE stands for Idea Network of Biomedical Research Excellence. So we do a lot of the research training that undergraduates around the state of Maine receive in biomedical research here. You know, there's also some mentored support for graduate students, postdocs, and new and mid-career faculty in that grant. But I just wanted to mention it to you because later what you're going to see is that your projects are really being built on top of this INBRE network. These are all of our INBRE partners that are going to be working with you in Maine. And by the way, New Hampshire is also an INBRE state, and so your mentoring network in New Hampshire is also going to be built on these INBRE partnerships. And I'll be showing you more and more about that as we go, but it'll help you to understand this context. MDI Biological Laboratory also holds what's called a COBRE grant. So we are also a center of biomedical research excellence here. And these funds are mainly to provide mentor support for new faculty. So the new young scientists that come in get some mentoring as they begin their own research careers. And so SEPA is really just the third in a series of these types of grants. They're all funded through the NIGMS, which is the National Institutes of General Medical Sciences. So as much as this looks like an environmental project, really it's nested in these biomedical research training opportunities that we offer here at the lab. Our research here is very focused these days on regenerative biology and aging. Those are like the main research fields here. But there's certainly an interest and certainly some research going on looking at how the environment interplays with development and regenerative capacity and the process of aging and those diseases that are related to the process of aging. So that just gives you a little sense of where SEPA fits into the granting picture here. So we also have a long history of working with high school students, middle school students, and their teachers, as some of you know because I've worked with some of you in the past. Back in the day, there was a program out of the National Institutes of Environmental Health Sciences, or NIEHS. It was called the STEER program, and it allowed us to have high school students come here and spend 7-8 weeks doing mentored research in laboratories. That program doesn't exist anymore, but we've been using some endowed funds to keep those opportunities open for students. And then, as I mentioned before, through our EPA Environmental Education program, we've definitely had more than one project going that's involved kids and teachers. We've brought them here to do all kinds of marine restoration and surface water work, and the EPA grant that funded the last arsenic project was, you know, the last in a long series of EPA environmental education grants that we had here. And then some of you here and others who became really invested in the work that you did with your students wanted to come back and even get involved in teacher-student research partnerships here. And so Maine Space Consortium and the Maine Community Foundation funded us to do that over a number of years. So I just want you to see that, you know, in a whole bunch of varied contexts, we have been working over the years with high school students and their teachers. And so this is just the crowning jewel. Maybe I'll retire. This might be my last project if I survive it. But anyhow, it's been fun. And some of you know that I myself was a high school teacher for 9 years. So somewhere in the middle of this busy career, I took time out and did my time in public schools. So I know the challenges that you have. I know that time is precious and difficult to come by. I know it's hard to communicate out of your classroom, that there's hardly time for that too. And so we kind of get where you're at, and I think that we'll all be able to work something out for ourselves here. There's SEPA, which is the last in this long list, and it's super exciting because none of these other funding opportunities really were very long-term. So they were all little shots in the dark, sort of 1 year, 2 year opportunities that I had to keep trying to get renewed. But this is a good long time for us to figure out what's really going to work for kids and teachers and communities. So here's a map that shows you the INBRE network in Maine and gives you some idea of where we are going to be working. So our partners in this project are Colby, Bates, and Bowdoin, and also the University of Maine, and many of its branch campuses, UMaine Machias, Farmington, the Honors College at UMaine, and also Southern Maine Community College. We have these two institutions that we consider outreach. They're not a regular part of our network, but we help to support some of their research efforts and research training efforts. That's UMaine Fort Kent and UMaine Presque Isle, and I think that's going to be a big, long reach for us. But there's very little arsenic data available in northern Maine, and I think this is a unique opportunity for those schools to link out, those institutions to link out to their local schools and really have kids involved in some purposeful work that might really get them charged to think about science careers. So this is the New Hampshire INBRE Partner Network. It looks a little bit like ours, but it's actually a little bit different. We just have one community college system label on there, but there's a lot of community colleges. So the New Hampshire tends to have a larger community college system, and we tend to have a larger branch campus system here. So I think that that might influence how we begin to put together what we're calling STEM satellite centers. So again, just as the INBRE-funded research training that we've done to date, and we've been the lead institution in Maine over the last 15 years, Dartmouth is the lead in New Hampshire, the focus has been on undergraduates. But SEPA is going to be focused K-12, and in terms of our project, it's going to be middle school and high school. So right now, we actually have what we envisioned as these STEM satellite centers emerging, which is really exciting. We have quite a few institutions in New Hampshire and in Maine that are ready to partner with teachers. And as you can see, I budgeted for 12, and we have 12 teachers here. And we have a couple extras that want to get involved, and we might stretch a little bit this year. But we're full up, and really the funding just came in August, and here we are in September. So I think we're doing pretty well with mobilizing on this project. And then I'm excited to see this map fill in years to come. The project involves a lot on top of the actual work with teachers and students and mentors. We have, like I said, a leadership team that it consists of Bruce and me and Anna Farrell here, and in New Hampshire, Catherine Lawler. And we will be meeting frequently to make sure the project is on track, and meeting with our external evaluators and our internal evaluator. There's going to be a summer Data Literacy Institute every summer, or a DataLit workshop is what we're calling it right now because it was truncated to a weekend. But this will happen in June, that same week I talked to you about earlier and was hoping to host this. These really, I think, do need to be 4 or 5 day experiences, and so we're going to be cramming a lot into this weekend, and we have an evaluation for you, and we're welcoming all your feedback, but we understand we're trying to get a lot done in a little bit of time. But I didn't think any of you could take a week off from teaching school at this point in the year. But in November, we're going to have the mentor training workshop, and all the mentors working with you are going to have very parallel training. So they're going to learn to work with the same website, the same data portal, the same data literacy software that you're training on, so that they're not talking Excel while you're talking Tuva, right? So we're going to get you talking the same language. We have a lot of meetings to go to disseminate this project. And so it's busy on both ends, but I think it's going to be something truly amazing. So here's the details of what are emerging. You might see that we already have mentors in mind for each of you. So in case in the introductions you didn't pick it up, these are all the schools and the teachers involved. And you can see we have partner institutions in both Maine and New Hampshire. And I hope to fill that in a little bit. You can see MDI Biological Laboratories taking on a lot right in our region, but we'll be looking for some additional mentors over time. And we have one company, Proverde Laboratories, that stepped up, and somebody heard about this opportunity, actually went to Gardner High School, wants to come back and be a mentor at Gardner High School. We could hardly say no to this scientist. So, you know, all kinds of things might emerge here that we didn't anticipate to start with. So, but at the heart of this project really is the scientific process, or what we sometimes refer to in our community lab as the scientific data loop. And the one thing that I've noticed over time is that teachers and kids really do have lots of good questions about the natural world around them. And actually through maybe citizen science interactions or other opportunities in their communities, they're pretty good at putting together some little experiments and collecting information. This I've seen. And as some of you alluded to during your introductions, this is where, at the data analysis and interpretation phase, this is where we see challenges arise and places where teachers and students and community members could use some help. How do you make sense of these numbers that are rolling in? And that's why we have Molly here and Tuva on board to help us with this. I think it's going to take some really novel data visualization to be able to get at this. And then also the communicating research, which is very tied into the analysis, because when you really understand the data, it's not that hard to talk about it, right? But we want to get the mentors involved in this too. And our hope is that the mentors will be working with you as you begin to try to talk about the data and the analysis that you've done, and that they'll maybe stick by you when you venture into some community meetings and need to talk about the data. And just the way Bruce is able to like step in with some, you know, kind of deeper understanding, maybe your scientist mentor partner will also have your back in these meetings. So overall, this is the way we did it with the EPA grant, and I think, as from being a public school teacher myself, I understand that you all have some great curriculum that you're already implementing. And so I'm inviting you to nest this arsenic monitoring project into the curriculum that makes sense. Some of you may create new curriculum, some of you may already have some existing projects where this fits really nicely. So we're not dictating that you have to do these activities and these exercises and march through a canned curriculum at all. But we do want each of you to go through this flow. So we're going to train the mentors, and together you're implementing a citizen science project in your classrooms, which really amounts to collecting water samples and sending them to Dartmouth. There's not a lot for students to do there unless you surround these activities with other curriculum. So after you have the arsenic data, and you'll be learning more, if not right now, then tomorrow from Duncan Bailey, our systems developer, you'll be learning how the data are going to come in from Dartmouth and get uploaded into the Citizen Science Data Portal. This is going to happen pretty seamlessly. We're not going to have you entering all of these data into the data portal. And this is to assure that there aren't any mix-ups. These data are so important that we're really, in this new iteration of the project, trying to eliminate points of failure or mistakes. And then everyone will work with Tuva and make graphs and maps, hopefully with some support from your scientist mentor. And then these community meetings are part of what we want to see you all doing. If your data don't get shared out to your communities, then there was almost no point in collecting it. Although we are going to have parents and kids at home logging into Anecdata and entering some information about the well, whether it's a dug or drilled well and that kind of thing. And so, there's, the parents are going to be a little more involved, I hope. and the students, by being involved in entering that data, I think will be a little more familiar with the whole portal. And then they're going to be able to go back in and find their results themselves, not wait for a letter to get mailed to them like we did last time. And not only can they look at their own data, but they can look at the whole data set. So parents that really want to see how their data nests inside of all the emerging data, I think that'll be interesting for them. And Duncan's worked out some really creative ways to keep the location and the names and the addresses private. So even though the parents and students are entering that in one end, that won't be visualized by anyone on the other. Okay, so that's kind of the overall. I just want to tell you what we're going to do over the next couple of days. I'm going to tell you a little bit about what it means to participate in the project overall. Talk a little bit about your classroom context for arsenic monitoring. I have a few ideas for you. I'm going to give you some hands-on stuff to do in the morning that might fit well. It might not, but I thought I would introduce you to some things. And I'm always happy, and Anna is, and Catherine is as well, to listen to your ideas. Also send you things that are occurring to us or that we're discovering somewhere. Well, I'll just talk a little bit about what Molly's going to do with you on the TUVA analysis, let you have a little peek into what that looks like. Talk to you about these student-teacher-scientist partnerships, because that's really, like, if you get into the literature on teachers and kids and scientists, mentors working together, there's a whole literature on it. And that's maybe how we got the grant, I don't know. But I want you to understand what that could possibly look like, and then what it's going to entail to share information with your communities, and then what are the next steps after that. So this is the All About Arsenic website. If you how many of you have been on the website already? So it's new. It's not the same one that we used for EPA, so don't make those assumptions. Go ahead and look in resources. There might be new things that weren't there before. So this website has a place to go to look at data and data activities and to link out to TUVA. It has some resources for you, some that we had from last time, but some new things that we've been finding and creating. What we're calling parent resources on here, we may change the terminology to like guardian, or I don't know, we can talk about that. I don't want anyone to feel excluded because they're not the parent of the child. Yeah. And then some information about the SEPA team. These are just some screenshots here, but you can play with this and see how it really works for you. You will enter your well water data here, but where you really go is out to anecdata.org, which is our citizen science data portal that is open to the public. That's why I was giving you those caveats that even though it's open to the public, there's some data that's going to be hidden. And that was a trick to accomplish. And Duncan actually had to put on his big thinking cap and solve that problem. That's a hard thing to do, to have some data one way, some data another way in a public site like this. So when you do that, you'll get into, this is anecdata now. You're not really on the All About Arsenic site anymore. And that's how it was last time. It was all self-contained in the website. That was not publicly viewable data. So that's one of the things about a citizen science project, is that really it has to be available. So I didn't have that citizen science word on the first iteration of this project with the EPA, but there we are now. And tonight, when we're talking about ethics and responsible conduct of research, we'll talk more about what it means to do citizen science, or what it means to be a citizen scientist, and all of the little ethical concerns that can bring up. All right, so you hit the Add Observation button, and you're brought to a page that has a place for parents and kids to enter their school name, their name, the child's name. Maybe we'll change that to student's name. I think we're thinking every minute of the day about how this evolves, and that's why I hope this weekend you look at everything, because this is early in the game and things can change and in ways that you think make sense. We want the city and state because we want students to be able to do some analysis around city and state. But the full mailing address will not be revealed to the public. and then the well type. And if you scroll down on this page a little bit, you'll see that one thing that's really important is that the parent gives permission to share the data with the Center for Disease Control or Department of Environmental Health Services in New Hampshire. This is the place where they do that, and we try to put a little bit of caveat on that, a little bit of explanation as to why we want to do that. It's actually up on the prior page. And last year we had like paper consent forms, and everyone signed them. Not too many parents last time didn't want that data in the larger data set, because that's really going to help CDC identify hotspots in places where maybe there really needs to be some state level attention to a public health problem. Okay. So the other thing that we have introduced is a discussion forum, and when you click on that on the website, it'll take you to a forum, and I've already put the first post on here where you can all start talking to each other. And maybe your mentors want to jump into the conversation. So it could be somebody else's mentor also sees your problem and decides to weigh in because they have an idea. We'll see how this emerges and whether we need it structured any other way, but I'm really hoping that we get a lot of cross-school, cross-satellite center communication going on that helps to inform all of us. I think it'll be helpful to our evaluators too, to have a little window into what people are talking about. Not that you can't always get in touch with us by email or some other way, but if it's something that seems like a good query to put out to the whole project list, let's use the discussion forum. Oh, and I wanted to go back for a second to the All About Arsenic website, because the Arsenic and You is a New Hampshire-based website that really has a lot of arsenic information on it that Bruce Stanton was just talking to you about. So that's maybe a good go-to website for arsenic information. Okay, so tomorrow morning, if all goes well, we're going to spend a few hours in the lab actually just playing with things. I have a copy for you of the teacher edition of Assessing Toxic Risk. There's a few organisms that are talked about here. There are lettuce seeds that people use. There's Lemna minor, which is duckweed, and I actually purchased so much duckweed that I'm happy to send you home with duckweed. I'm trying to culture these little guys on the book cover. They're called Daphnia, like water fleas, and I don't know if I have enough to send home with everybody because I'm still figuring out how to rear them here. And so here's some pictures from the lab I took yesterday. But we did set up some arsenic studies for you. And I have been growing Lemna in different concentrations of arsenic. And I've been rearing Daphnia in different levels of arsenic. And so tomorrow, you get to be the ones that check in on them, not me. I'm done with counting Lemna fronds and counting Daphnia heartbeats. I'm going to let you do that. I can share with you my previous data, and then we can put it together and see, is there something emerging here that's interesting? I have to tell you that I think what's going on with arsenic in these organisms is subtle. And I also think I needed to have set up more replicates to get to statistical significance. So I'm learning here, and I'll share with you what I learned. So I do want you to try some substance that we know will give you a kind of response to dose that will be obvious to you. And so we can play around with alcohol a little bit, and that really does impact heart rate in Daphnia, just so you can get a sense of how to work with these little guys and get their heartbeats going and count them. I've worked out some tricks for myself. Maybe you have some tricks for yourself too. There are YouTube videos of people counting heartbeats out there too that might help you out. And then Molly's going to help us think about later in the day, is there a way to take experimental data, not just like long-term monitoring data, but experimental data like that, and get it into TUVA and answer some questions that way? So not only will you have your arsenic data to play with in TUVA, but I'd like you to be able to take your own experimental data and get it into TUVA, right? So I don't even know how to do that yet, so I got data, you have to show me how to do that. So then tomorrow afternoon, you're going to spend significant time really clicking through the website, learning how Anecdata works. If any of you has another classroom project that you think, wow, I didn't know anecdata.org existed, I want to set up another project for something else I'm doing, we can help you do that while you're here to really familiarize yourself with how to use that data portal. We now have hundreds of projects and thousands of users on that site from all over the world. It really is becoming a go-to citizen science data portal, and we're pretty proud of it. And so you'll work with that extensively with Molly while we have her here. Like, I really hope you know the ins and outs of Tuva by the end of the day tomorrow and have a little time to just play around yourself or in teams. Anyhow, it was Sunday morning that we were planning on taking you through from beginning to end what you have to have your students doing to collect that sample and get their data, entered, and what it's going to look like when the data comes back and how they're going to interface with the system, and let you shop a little. We've been buying things to kickstart your work so you can see whether or not you think you want some tubes or lemna or what, and we'll pack you up. So the arsenic project on Tuva has its own landing page. They have created for us our own workspace. You can help us too with building out this workspace. We can have documents on here, or we can just link out to other documents from here. Molly actually took our data set from the EPA project and threw some of it into Tuva and took a look at it. I included this in the data application I sent to NIH, and I think you can see right off the bat that it's a unique look. You don't often see graphs like this out of Excel or Pages or anything like that. So you'll see how it works. It's very dynamic. This graph doesn't just pop up. The system shows you how this graph was assembled, which is pretty cool. And it has mapping capabilities too, which is another way to visualize data, to share data, and talk about data. So just so you're clear, this is what we have shared with the mentors who may come in and help you with the Tuva software and other things. We want them to attend a mentor workshop, just like this workshop that you're attending. And we expect that they will gain familiarity with that software. And we want them to actually come and meet you in person. And this would be maybe outside of the regular school day, maybe after school, maybe before school, and just talk to you a little bit of what's your plan? Where are you going here? When would you like me to come back in and interface with you? I'm hoping that at least one time they will come into your classroom while your students are engaged in some aspect of this work and talk to your students. And my hope too is that you'll get to know them a little bit and your students will get to know them a little bit. I'll bet you some of these people will want to come more than once, but I didn't want to put too many requirements on, or I didn't think anyone would sign up. I hope when you get down to the end of the day and your data's all in Tuva and you've got these graphs and these maps and these things that you want to share with your community, that your scientists will help you look at that and make you feel confident, like, yep, we asked the good questions and we're looking at this the right way, and what we have to say in the community is going to be spot on. And I'd like to see them at that community meeting with you. I hope that they can. You can understand that there might be just that difficulty in getting them there. However, last time Anna and I attended many, and I know Catherine attended some in New Hampshire, so somebody's coming to have your back. And then we do hope that you write case studies. There's a lot of room here, and there's room through the whole 5 years, but there's no obligation to do this again and again and again, right? So we're trying to give you some freedom in terms of how much you do, how often you do it, and in what kind of context you do it. I think that's all going to just be what makes this interesting, is to see how it all plays out for everyone in these two states. Okay, so with that said, I don't know if these will remain my long-term goals, but this is kind of what I came up with for the grant. We had to do this, what's called a logic model, And most of the specific aims for my grant were more immediate, like get you here to a workshop and get you on tuba and get you back in your classrooms doing this kind of stuff with kids. And but beyond that, we're really hoping to see that this work builds the skills that allow you to really affect change in your communities. So it's bigger than just going to the workshop, learning the skills, but where is that taking you? And we're hoping that by monitoring wells for arsenic, there's positive public health outcomes. And we're talking in our evaluation team about how do you assess that? That is almost another project to try to track everybody and find out what they did, with the data that they were given. What kind of decision making did people do? Did they put in filtration systems? And then to follow people, so then did they check their filtration systems, like Bruce was saying? People tend to not do that. So there's some interesting long-term studies that could go on here. But that's just a long-term goal of mine, that there are these positive public health outcomes. And to tell you the truth, I'm hoping kids get really jazzed about science and decide to take more science courses and choose science majors and maybe decide to join us in this career path that we've all found ourselves on, either as scientists or educators or scientists/educators or whatever we are. Because it's been, a rich life for me, and I would hope that there's some kids that come along with these kinds of passions for connecting their science to their communities, which is, why I keep going.